What do you mean by cross product of two vectors? Or it is simply known as vector product of two vectors. Let us consider we have two vectors, vector A cross product vector B. Mathematically it is equal to magnitude of vector A multiplied with magnitude of vector B times sine theta into n cap, where theta is the angle between these two vectors. N cap gives the direction of the resultant vector. So this is a scalar quantity, this is also a scalar quantity, and this is also a scalar quantity. So this whole thing is the magnitude of the resultant, and this is the direction of the resultant. So the resultant is a vector quantity. So cross product of two vectors gives a vector which has a magnitude which is equal to AB, or simply we can write AB sine theta, and n cap gives the direction of the vector. So if A and B are the vectors where theta is the angle between them, how do you find the resultant vector? So in order to find the resultant vector of cross product, we have to use right hand thumb rule. So this index finger points toward the first vector. The first vector is A, and the middle finger points towards vector B. So we have to align our two fingers in the direction of vector A and vector B. So index finger points towards vector A, which is in this direction, and this middle finger points towards vector B. So in this way we can point both vectors. Now the direction of the resultant is the direction of thumb, which is in this upward motion. So if this is vector A, vector B, then the resultant of cross product of two vectors is this vector. Now we can see vector A and vector B are coplanar vector which is on the same plane, whereas the resultant is on another plane. Here the first vector is very important because the index finger points towards first vector. Let's see B cross A, which is equal to BA sine theta n cap. N cap is the resultant vector. Here both may seems to be same, but when we use right hand thumb rule, when we see the first vector is very important because the index finger points towards first vector, which is in the direction of B vector. So here the index finger points towards this vector, and now the middle finger points towards second vector. If this is in the direction of B, in order to represent this finger in the direction of A, we have to do like this. So now this index finger points towards B, which is first vector, and this middle finger points towards vector A. Now this thumb gives the direction of resultant vector, which is inward of this board. So the resultant vector is going inside this board. Here for A cross B, the resultant vector is upward, whereas B cross A, the resultant vector is inward. Both are opposite to each other. It means A cross B is minus B cross A, because the magnitude of both are same, whereas the direction only differs. Thereby the resultant are different. So this is the mathematical understanding of cross product or vector product, where two vectors are multiplied or cross multiplied to give a vector quantity. Now why do you use cross product? We'll see an example. This is a screw. When we try to move in clockwise direction, the screw goes inside. But when we try to move it anti-clockwise, the screw goes upward. Why does the screw moves upward or downward? Here the action is only circular movement, but the result is moving upward or downward. Let us analyze this thing. Let us take this plane. So if we take here vector A and vector B and we find the cross product of these two vectors using right hand thumb rule, we'll find the resultant direction. So this is vector A and this is vector B, so the resultant is upward. So the resultant will be upward. Here we can put B vector as this. So this is in anti-clockwise direction. So if we try in anti-clockwise direction, the screw moves upward. But if we try B cross A, it means we try B cross A. So if we put index finger in this direction, B direction, and this middle finger in A direction, the resultant is downward. The resultant is downward. So if we try in clockwise direction, the resultant is inward. So here we can see cross product helps in understanding the turning effect. So cross product means what is the effect of turning, whether it is inward or outward. We know A cross B gives AB sine theta n cap, where n is the direction of the resultant vector. If theta is 0 degree or 180 degree, we know sine 0 degree is equal to sine 180 degree, which is equal to 0. So A cross B will be equal to, if sine 0 is 0, so whole things become 0. But if theta is 90 degree, sine 90 degree is 1. So A cross B is equal to A times B into 1 is equal to AB. So this is the maximum magnitude of a resultant vector. So if vector A and vector B are at 90 degree, the resultant vector have maximum magnitude. Cross product or vector product do not obey commutative law. What is that? If A cross B is AB sine theta n cap and B cross A is AB sine theta n cap, whereas here and here they are opposite to each other. It means their direction are opposite to each other. Thereby A cross B is equal to minus B cross A, because both resultant vectors are opposite to each other. The vector product obeys distributive laws. That means C cross A plus B vector is equal to C cross A plus C cross B. If we carry out vector product of a vector with itself, which means A cross A will give A times A sine theta n cap, which is equal to a square sine theta n cap. We know these two vectors are the same vector, so theta has to be 0 degree. So sine theta is equal to 0 because sine 0 is equal to 0. So a square times 0 n cap, which is equal to 0. So the cross product or vector product of a vector with itself is 0. A cross B gives A B sine theta n cap. When this is vector A and this is vector B, if we draw a parallelogram using these two vectors, this is also vector B and this is also vector A, then the area made by this parallelogram, area of, let it be A, B, C, D, A, B, C, D, will be equal to magnitude of A cross B, which is equal to A, B sine theta. This is the magnitude of A cross B, which will be equal to the area made by these two vectors when formed a parallelogram.